Every year, the world's most sophisticated corporations spend billions of dollars on risk management protocols, compliance departments, and predictive models. Yet, when global crises actually strike, these highly engineered systems routinely collapse. The problem stems from how corporate risk is traditionally defined. Standard practice relies almost entirely on probability forecasting, guessing the likelihood that a specific event will happen, and estimating the financial damage it will cause. This chart shows the standard tool for that job, the Probability Impact Risk Matrix. Analysts plot potential threats on a 2x2 grid, ranking them by how likely they are to occur against how much they might cost. But mapping historical data onto a clean graph creates a dangerous illusion of control. It assumes that future threats will neatly resemble past events. Consider the Deepwater Horizon explosion. A sprawling apparatus of compliance rules, safety matrices, and operational forecasts entirely failed to predict the specific cascade of mechanical and human errors that led to a fatal blowout. Or look at the 2011 Fukushima earthquake and tsunami. It was an external shock so massive and mathematically improbable that traditional risk matrices simply had no mechanism to capture it. These traditional models fail because they are designed to predict the trigger of a crisis. They do not measure a system's vulnerability to the consequences of that crisis. To understand why predicting triggers fails, we have to look at the math. Corporate risk managers frequently use standard deviation to measure market exposure and build their models. Standard deviation works perfectly well for what statisticians call tame randomness. In closed systems with predictable variables, like casino games or life insurance mortality tables, outcomes reliably cluster around an average. But modern global value chains do not operate in closed systems. They are highly complex, deeply interdependent networks driven by erratic, nonlinear variables. In an environment of socioeconomic randomness, standard deviation is completely useless. Market shocks and supply chain failures routinely exceed 10 or even 20 standard deviations from the historical mean. Analysts look at decades of stable historical data and draw straight lines into the future. They assume an extreme shock won't happen simply because it hasn't happened recently. This leads to dangerous confirmation bias. Executive teams naturally favor data that supports their optimistic projections, systematically suppressing evidence that contradicts their carefully built models. The human brain also misinterprets the math itself. Tell a board of directors that a crash happens once every 1,000 years, and they feel safe. Tell them there is a 0.1% chance of a total crash today, and they panic. The math is identical, but the psychological reaction dictates the policy. This brings us to a mathematical axiom. Predicting the exact timing and magnitude of a highly improbable, high-impact event in a complex system is practically impossible. Attempting to forecast extreme events using historical probability models generates a false sense of security. It leaves corporations entirely exposed to sudden systemic failure. If predicting the exact cause of a disruption is statistically impossible, the operational strategy has to pivot. Organizations must mathematically model the consequence of a disruption instead. This requires a structural shift in thinking. Global value chains must be analyzed not as isolated business units, but as a dense network of interconnected operational nodes. To evaluate this network, we introduce a critical metric, time to recovery, or TTR. TTR is the exact duration required to restore a single disrupted node, whether that is a supplier, a manufacturing factory, or a transit hub, back to full functionality. Crucially, this metric is calculated without knowing the cause. For the purpose of the model, it does not matter if a factory goes offline due to a labor strike, a hurricane, or a massive electrical fire. The node is simply down. Once the node is isolated, companies use linear optimization models to calculate the exact financial performance impact the firm will suffer during that specific recovery window. Depending on the business, that performance impact can be quantified in lost units of production, total revenue forfeited, or direct erosion of profit margins. By isolating individual nodes and calculating their recovery time, firms bypass the need to predict the future. They can quantitatively engineer resilience against outages, regardless of what extreme event triggered the failure. To see consequence modeling in practice, look at Ford Motor Company. Ford analyzed structural failure points across 1,000 different supplier sites. From this data, they calculated a second critical metric, the Risk Exposure Index, or REI. The index is calculated by finding the single node in the network that causes the highest financial performance impact if it fails. That node is scored a 1.0, and every other node is indexed relative to that maximum risk. This scatterplot maps Ford's data, performance impact against total spend. There is zero correlation between money spent and actual financial risk. Traditional management obsesses over the top right quadrant, high-spend strategic components. But true danger lies in the top left, the hidden risk suppliers. These nodes represent cheap, low-spend commodity goods, like specialized valves or simple O-rings. If the single-source manufacturer of a 20-cent part goes offline, a multi-billion-dollar assembly line grinds to a halt, just as surely as if the engine supplier had failed. In 2012, an Evonik chemical plant suffered a devastating explosion. They supplied a specialized resin used in fuel tanks and brake components. That single, hidden, low-spend node effectively bottlenecked downstream production for the entire global auto industry. The solution is redirecting capital toward mitigating these high-index nodes. Companies can secure dual sourcing contracts, stockpile excess inventory of cheap parts, or design more flexible manufacturing processes. The Risk Exposure Index proves that existential threats often hide in the cheapest parts of a supply chain. Relying on traditional, spend-based risk assessments leaves complex corporations dangerously exposed. Once a firm accurately maps its structural vulnerabilities, risk management stops being a defensive compliance exercise. It becomes an offensive strategic asset. This opens the door to business model risk restructuring, deliberately altering contracts and operational flows to shift exactly where risk lives within a value chain. In the late 1990s, Blockbuster restructured its model by shifting inventory risk back to the movie studios. Instead of paying a high fixed price for tapes and risking unsold inventory, they negotiated a low upfront cost coupled with revenue-sharing contracts. Zara built its retail empire by shifting demand risk. Rather than predicting fickle consumer trends months in advance, they utilized hyper-fast, higher-cost local supply chains to produce clothes as trends emerged, eliminating the risk of massive, obsolete inventory. Sometimes the most effective strategy is a counterintuitive one, intentionally adding risk. If a firm possesses a superior operational capability to manage a specific risk, it should actively absorb that risk from its customers. Rolls-Royce did exactly this with their Power by the Hour model. They absorbed the existential risk of engine breakdowns from the airlines. Instead of selling the hardware and charging for repairs, they charged only for the miles flown, taking the maintenance liability entirely onto their own books. True strategic advantage occurs when a firm deliberately restructures its business model to absorb risks its competitors cannot handle. It aligns incentives, proves operational superiority, and dominates the market. For decades, modern corporations have spent millions attempting to predict the exact timing and nature of socioeconomic shocks. It is an impossible task. Organizations must abandon probability matrices and standard deviation models that rely on clean historical data, and instead adopt node-based impact modeling. Tools like time to recovery and the Risk Exposure Index allow firms to illuminate the invisible bottlenecks that can easily destroy a massive interdependent network. Risk is not a line item for the compliance department. It is a foundational building block of corporate strategy. To survive in a complex global economy, leadership teams have to stop trying to act as oracles and start acting as architects. The most resilient organizations operate on a simple premise. The trigger of the next crisis is inherently unknowable. Instead of guessing, they mathematically map their node vulnerabilities, and they manipulate risk as the ultimate architectural lever to secure industry dominance.